Okay, we're in section 39. This is going to be volumes, and we're going to get these volumes by rotating a curve about an axis. That axis is generally either the x-axis or the y-axis. And when we rotate, we're going to be trying to visualize what's called the disk. If the disk has a hole in it, it's going to be a washer. So here's the deal. We're going to go read this through you. We'll look at the pictures, we'll generate the integrals, and we'll finish the example on this page over here, which is the lecture. Just one page, right? Here's the deal, though. I'm not saying you're going to get it with one example. What we're going to do is we're going to do other examples. The problem most students have, though, is visualizing what we're doing. And that's a problem. You need to be able to visualize it. You also need some basic skills. The basic skills here is the volume of a disk, which is pretty simple. It's just the surface area times the thickness of the disk. And these are circular disks, by the way. So the surface area is just going to be pi r squared. We'll go through many examples, but lecture, we're just going to introduce one example. Here's the deal, though. After we go through a bunch of examples, you're expected to go off on your own to do your own examples. Of course, the work is down there, and you want to be able to match your answers. And of course, I will say this over and over again. I'd also recommend reading your textbook because, by the way, the pictures that I'm lifting at over here are basically from a textbook. Now, I'm not saying it's from your textbook. I can't remember if this was taken from the last book we did or the book before that. We changed books a lot. Here's the remarkable thing. You look at the books, the pictures are all the same. They're all the same picture. All right. So yeah, I did lift these pictures out of your textbook. When I say that, I'm not sure if it's your textbook or the one we used last semester, or even like 10 years ago, or 20 years from now. Basically, I'm the same pictures, right? Why the pictures brought to you? To provide information about what we're doing. I'm going to say I'm opposed to memorization, by the way. However, some students, everything's a memorization. I got to be honest with you, though, there's no way I'd want to memorize this stuff. I want to understand it. And that's my goal, is to get you guys to understand this material. Let me switch screens. And give me a second to do so. And I'm going to read. And certainly this is what we're talking about. We're going to read this stuff to you. The part of reading is, certainly we want you to read as well. And, what I mean by that is you read the notes. Certainly when you move on to another school like NJIT or something, where much of our students go, I would recommend before you attend lectures, get the book, read the book, and then attend the lectures, all right? So this is going to be volumes of revolutions. All right. So right now I'm trying to realize what they're doing is they're rotating something. So what I'm going to do is talk about that this is going to be a method of disk. If there's a hole in it, it'll be a washer. All right. So, what does a washer look like? A disk looks like this. Let me put that down for you. This is what a disk looks like to me. It's got a surface area and a thickness. If I did a washer, it would look like this with a hole in it. Sort of like a wheel or something, right? Something like that with a little hole in it. All right. So I'm going to claim over here, I don't want to memorize things. I want to just understand what they want me to do. And over here, I'll read, it says, if f of x is continuous and it's above or equal to 0 on some interval, closed interval, then the solid table rotating the region under the graph about the x-axis has this volume over here. Now, again, I'm looking at this over here and says, well, that's good enough by me. I'll just remember that and I'll do the problems using this formula. And my goal over here is not so much to use the formula, but to kind of understand it. All right. So we'll discuss the formula. I want to understand it. So I'm going to suggest you should make some good effort to understand things. Of course, as we do examples, your understanding will become improved. But I'm going to say, I don't think it's a good idea to memorize. Like someone says, well, I don't want to memorize. I don't care what you say. I want to memorize. Here's the deal. I just don't think it's a good idea. I want to try to understand this. So I'm going to read the first question. It's an example. This is going to set the tone for the problem set. All right. So it says, find the volume that's obtained by rotating about the x-axis, the region of the curve y equals x. Well, what I want to do is I want to kind of visualize what this y equals root x looks like. And I'm going to say it looks sort of like this over here. And it's between 0 and 1. And the region that they're talking about, we've done many times before, is already shaded in for me. Now, what do I normally do? I normally do the area, right? So what have I done? I've done a rectangle, and I'm hoping you remember that. We've done that rectangle before many times, right? I'm going to do it a Riemann sum. But now we're not adding rectangles together. What we're doing is we're rotating. And if you were to rotate that rectangle about the x-axis through a full 360 degrees, what you generate is you generate an object that looks like a disc. I'm just tracing over it. Then someone says, what's the volume of that disc? Well, the volume of a disc is going to be the surface area, and that's going to be pi r squared. That's the surface area of it. That's this thing over here times the thickness of it. I'm going to call that width. All right. So then the question comes is, well, there's a lot of discs to do, right? One at a time. So what we're going to do is we're going to use integration to add all the discs together. And where did the disc start? Well, if I thought about it, I'd start over here and it'd end over there. So I'm going to say 0 to 1. And what's the differential going to be? The differential is going to be dx. I normally do this first, by the way. I normally discuss the differential, the limits, and then I try to figure out what the integrand is going to be. Well, here's the deal. The width of the disk is actually just dx. Then the question comes is, what's this thing over here? It's pi, the radius of the disk squared. Well, what's the radius of the disk? Well, if you thought about it, it's just the function's value at x, which is just root x. All right, I have my integration set up. I'm going to do the integration now. So what do you get over here? 0 to 1, pi x dx, integrate pi x squared over 2. Generally speaking, these will be easy to do. If not, we'll need a tool to do it. 0 to 1, what do you get over here? Pi halves minus 0, which is pi halves. What is that? Cubic units. We get this. All right. Let's repeat this. Someone says, well, I'm going to use a formula. You get the same answer. You get the same integral. Get the same limits, all that kind of stuff over there. You're going to see me visualize. I'm going to be using images that I grabbed from a book somewhere, and your book has a lot more images than I could provide to you. Please look at your book. Please read your book. Please try to make sense out of it. Please don't try to memorize these things. They're really simple problems, provided you can visualize the region and the rotation and the disk. When you do it in that order, the integral will go down incredibly quickly. Now, what do we have to get busy with? We have to get busy with more examples. Relatively speaking, those examples will follow this example here. What is that? Graphing, visualizing the region, visualizing the rotation. Once I visualize rotation, I see the disk. Once I see the disk, I can do the volume of the disk, and then I can add all the disks together. As long as I know what the differential is, I can do that. And we're going to do one after another. All right. Hopefully this has been helpful, but I realize it's just an introduction. And introductions sometimes aren't all that helpful. It's when we start doing more and more examples. And the point of this is when we start doing things, you should come to the stage in life where you say, I want to try. And that's where you're going to start to do the homework. Thank you.